So I'm going to take a slightly different angle than I think most of the others. It's always tough to be the last speaker because all the good ideas are gone. So now I have to like make shit up as we go along. But I'm coming at this from the perspective of someone who builds large-scale systems, right? Whether it's commercially through Radium, or for academic people who are submitting their NeurIPS or ICML papers, right? But we build large-scale systems where a lot of these AI solutions are going to be built. And we have a huge problem as we're building these systems. We're starting to hit power, cooling, all sorts of limits. You're building larger and larger models, which means we need to deploy more and more systems. There's power, there's energy, there's all sorts of stuff going on, right? And people are building amazing things, right? Like Climate GPT was mentioned earlier, right? Bringing that scientific knowledge of like severe weather, putting it into a language model, amazing. Right? We have people who are doing research on improving flight optimization paths so you can avoid contrails. Huge benefit to society, to the climate. Great stuff on just weather prediction. AI for materials, right? Can we build products faster to even help with climate change, right? Products that we can use to absorb or be a part of that, right? So great opportunities. We've seen them, autonomous systems, that's actually where I did my graduate work, right, can help, if we can move to autonomous systems, we can actually reduce emissions coming out of vehicles as they can drive more carefully, leverage, you can have trucks that are closer together, some really, really interesting stuff. But as we're building all of this, one piece that we should not forget is to add to the problem in building these solutions for the environment, right? So are we making the environment worse? Or are we making it better as we're building these? So just a few things. Data center usage right now, globally, is probably about 3-4% of the global energy demand. That's huge. It's larger than the airline industry in terms of the energy use and associated emissions with that field. Training a model can use hundreds of metric tons of carbon dioxide equivalent. It can release that much. That's training one model. Inference is a whole nother beast, right? I've seen estimates anywhere from 1,000 tons a day to 10,000 tons a day, but it's somewhere pretty big. And those are often in places where you don't get to control the energy mix as closely because you're trying to put them as close to the edge as possible. We are definitely seeing that a lot of the data centers that are coming up are in places where they're using water cooling, right? You have to, as you're getting more and more dense in each of these racks, you have to be creative in the way that you're actually cooling this hardware. It does not like when you go above 80 degrees centigrade, I can tell you that for sure. We have done that quite a few times. And so now we are bringing water in from water-stressed areas, watersheds that are not necessarily designed for this. And so we're creating a large problem as we go along. And so the question is, can we, from the computing perspective, build better products in order to address this? And I like to think of this, how many people here submit to a lot of like machine learning or AI conferences? Probably quite a few. You have to sign this like ethics statement nowadays, right? Like if you're submitting a paper to NeurIPS or ICML, there's a whole like, did you steal someone's data in order to make this paper? Those type of questions. Why aren't we asking questions about how the energy was utilized, right? If you burnt an entire rainforest to give me 1% accuracy improvement on telling the difference between cats and dogs or telling me a slightly better joke, we as a community need to be in a position where we can evaluate whether that's what we want, right? And whether that's something. So I see this as actually an ethical problem. And we need to elevate this to the level of fairness, bias, the other topics that we often talk about when we're talking about what we need to be concerned about in AI. So I want to elevate that. But this is supposed to be an optimistic thing. So, there's a lot of things we can do today. And some of these are going to be a couple of behavioral changes, and some of these are just things that we can take care of, right? So the first thing is we can share data. Right now, I don't know. I can tell you what's sort of coming off of our systems, but on large-scale applications that we all interact with on a day-to-day basis, I really don't know what the actual energy use is. Where is the energy coming from? How are we going to measure that, right? So we need to, as a community, start to demand that. And everything we talk about is on operational data usage. We have no clue on the embodied side, which is I'm buying new hardware. What is the carbon emissions associated with that from where I brought it? So that's something I think as a community we can work together on, of making this data available, sharing it publicly, and then working on solutions together. Every time we make data available, we tend to be pretty creative with coming up with solutions. The second thing is, coming up with ways that we can educate and make people aware. I don't know how many people are aware that every time you ask ChatGPT a question, something in the rainforest dies. I mean, not really, but it can be pretty bad, right? I mean, and I don't mean to pick on ChatGPT, but any of these large language models or generative AI models, they do have a pretty large carbon output. I mean, I certainly stopped asking, Stability to generate random images once I found out how much energy is used every time I do that. And I'm like, maybe I can hold off on doing some of these things, right? Some of these are just silly. And then we can also use AI to help us make these systems better. We've done a lot of experiments where we can just limit the power to one of our GPUs. And that is a huge long-term effect. It can reduce energy usage from our data centers by about 20%, improve hardware reliability by similarly, which means embodied carbon goes down. We can do all of this with minimal latency, right? It doesn't increase by very much the performance of your algorithm. It's just a simple setting that we need to make. It's really that simple. I think we need to make our software now environmentally aware, which means carbon emissions need to come into our software program. I'll just give you a very simple example. How many people are familiar with like computer vision model like YOLO? Right, quite a few. There's a few versions of these. We did a simple experiment. We added carbon emissions, like carbon intensity, real-time carbon intensity, into our inference engine. And we allowed the inference engine to move between a couple of different YOLO models, right? YOLO V8 and YOLO V5 and YOLO V3, I think. Each have a very different energy output. What we were able to find in that simple experiment is if we were to basically at times of high carbon intensity use a lower quality model and at times of low carbon intensity kind of go full bore, we actually were able to reduce carbon emissions over a 48-hour period by about 70% with an accuracy reduction of about 2%. So that's a trade-off I think a lot of us would be okay with. We did the same thing with ChatGPT. When we have high carbon intensity, we give a generative direction to basically reduce the output token length, similar results. So are we as a community willing to trade off a little bit of quality in order to have these outsized impacts to the environment? And that's something, again, we need to work with the companies we're working with to say, yeah, we're willing to take that trade-off, right? And we're willing to, if I'm asking you who the president is, I don't need an essay and a tree in a rainforest going away. I'm okay with just the answer and let's move on to the next thing, right? We can not be wasteful. I think we talked about, Himanshu was talking about the generation of the light bulb. AI is very similar to that. People run thousands of experiments to figure out which model or which settings they want to use. Whereas we can apply a little bit of logic in doing that and actually reduce most of those computations very quickly. So we did a simple experiment in the world of material design where we essentially just tracked the loss curve of a model that we were training for a hyperparameter optimization job. And we were able to essentially eliminate 80% of the jobs from the get-go because they weren't following the right trajectory for where we want a loss curve to go. So just like that, we were able to reduce 80% of the computation, energy, carbon output with zero detriment or zero loss to the actual end output. So I know I'm out of time here. So I'm going to end with, I think there's a lot to be optimistic. AI can be super helpful, but we should just make sure that we're being good stewards of the environment while we're building these. And so these are questions that we all need to ask.
Also.